the Thévenin theorem, a linear circuit can be replaced by the Thévenin voltage, that's the open circuit voltage, in series with the Thévenin resistance. So for this question, we are going to redraw the circuit. We are not going to change anything apart from removing the 3 ohms resistor and replacing it with an open circuit. So what we are doing is that we are going to find the open circuit voltage when the 3 ohms resistor is removed. So we are going to put an open circuit at this side. Then later on we are going to calculate for the open circuit voltage across it. So when it comes to the direction of the open circuit voltage, you can either choose this way or the other way around. So what you are going to do is that you are going to use KVL to find the voltage that is across the open circuit. So first thing you are going to do is you are going to take a loop through this side of the circuit. So for that, you are going to get the 35 volts plus the VTH, which should be equal to, according to the voltage law, the sum of voltage sources should be equal to the sum of voltage drops. So we are going to have 35 plus the VTH equal to the 6 times the current through the 6 ohms resistor. So the VTH is going to be 6 times the current minus the 35 volts. But then one thing we don't know is the current, so we are going to use the other loop to find the current through the 6 ohm resistor. So for that one, you're going to take another loop. So 42 volts, sum of voltage sources should be equal to the sum of voltage drops. So you are going to get 42 to be equal to 18 times the current. So the current is going to be 42 divided by the 18, which is going to give you 7 on 3. So the 7 on 3 is going to be the current that is across the 6 ohm resistor. So with that in mind, we are going to do a substitution here to find the VTH. So the VTH should be equal to 6 times the current, which is 7 on 3, minus 35, and that is going to give you minus 21 volts. So let's move on. So now we know that VTH is minus 21 volts. So we found our VTH. The next thing that you would have to consider is finding the Thévenin resistance. So one thing that you should consider when you are finding the Thévenin resistance is that all voltage sources should be short-circuited. So we are going to redraw the circuit again, but this time we are going to short-circuit the voltage sources. So the 42 volts is going to be short-circuited. We are still going to have our resistance. Then we are going to have our 6 ohms resistance over here. like that. So for this particular configuration, we can see that the 12 ohms is in parallel with the 6 ohms. So just like how in the previous videos we find the equivalent resistance for resistors in parallel, which is going to give you 4 ohms. Now once you have found your VTH and your RTH, the next thing to do is, you see, according to the Thévenin theorem, a linear circuit can be replaced by the Thévenin voltage in series with the Thévenin resistance. So we are going to have a Thévenin voltage and then our Thévenin resistance RTH. This is VTH. Then it's going to be in series with the 3 ohms that we removed earlier. So we realize that the RTH is in series with the 3 ohms resistor, which means that the current through the RTH will be the same current through the 3 ohms resistor. So the VTH is minus 21 volts. So what you are going to do is, this is a simple KVL situation. So let's just say there's a current going through the loop like this. You're going to have minus 21 to be equal to the I, which is the current through the 4 ohms resistor and the 3 ohms resistor, since they are in series. So that should give you this to be equal to minus 21 divided by 7. So that should give you minus 3 amps as the current through the 3 ohms resistor.